The problem is from GATE 2022 mathematics paper, question number 13. The problem given is consider the real function of two real variables given by u of x comma y equal to e to the power of 2x times sin 3x cos 2y cos h of 3y minus cos 3x sin 2y sin h of 3y. Let v of x comma y be the harmonic conjugate of u of x comma y such that v of 0 comma 0 equal to 2. Let z the complex number given as z equal to x plus iy and f of z equal to u of x comma y plus I times v of x comma y. Then the value of 4 plus 2i times f of I pi is, the four options given are option A e to the power of 3 pi plus e to the power of minus 3 pi. Option B e to the power of 3 pi minus e to the power of minus 3 pi. Option C e to the power of minus e to the power of 3 pi plus e to the power of minus 3 pi. Option D minus e to the power of 3 pi minus e to the power of minus 3 pi. So from the given problem we can see u is a function and v is the harmonic conjugate. So whenever we have a harmonic function u, we can see we always can find a harmonic conjugate v such that unique, whereas v can be unique and u plus iv as defined by this relation is analytic. So and the NPTEL reference to solve this problem is module 2 lecture number 6 of complex analysis. The title of this lecture is Sine, Cosine and Harmonic Functions by Professor P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this YouTube lecture with using this YouTube link. So now coming to the solution. Given that u of x comma y is the function e to the power of 2x times sin 3x cos 2y cos h 3y minus cos 3x sin 2y and sin h 3y. Sorry, this is y. So this is our real part of the function f of z, and it is given that v of x comma y is the harmonic conjugate of u of x comma y, and moreover given that f of x comma or f of z equal to u of x comma y plus I times v of x comma y comma v of 0 comma 0 equal to 2. Then it is asked that the value of 4 plus 2i times f of I pi. So from the given from the thing what it is asked to calculate, we can easily see it is asked the value of f of I pi. So if we can calculate the value of f of I pi, we can easily see the whole value of this expression. But the given hypothesis only is u is the this function and v is the harmonic conjugate and v of 0 comma 0 is nothing but 2. So whenever we have the real part or imaginary part of an analytic function, the analytic function can be calculated in the following way, that f of z is equal to integration ux of x comma z comma 0 minus uy of I times uy of z comma 0 dz plus c, where c is some constant independent of x and y. And this is in terms of ux whenever we have a real part. Or a similar kind of formula is there whenever we have the imaginary part of complex number, sorry, imaginary part of that analytic function. So since here c is independent of x and y, that is independent of the complex number, we cannot say the function f of z is unique. So whenever we have analytic function, sorry, whenever we have a harmonic function u, so we can find many analytic functions such that u can be with either imaginary part or complex or real part. Since here u is given this function, we can find an analytic function f of z like this, but it need not be unique. But from the given condition, we have another condition that v of 0 comma 0 equal to 2. So from this we can calculate the value of c, and hence in total we can calculate the function f of z uniquely, and from that we can see the value of f of I pi. So now by using this formula we can see, or firstly let me give a reference for this kind of formula. So the reference is, can this kind of formulas can be found from the textbook complex variables and applications. This is the title of this lecture by Brown and Churchill. This is a famous textbook for complex analysis. So now by using this formula, we see the function f of z is integration ux of z comma 0 from the function u. Okay, firstly let me calculate the partial derivatives ux and uy. Then we'll directly substitute in this formula. So we have ux of x comma y from the given function u, as we have 2 times e to the power of 2x, the remaining part of the function, that is sin 3x cos 2y cos h 2y, or sorry 3y, minus cos 3x sin 2y sin h 3y, plus e to the power of 2x times 3 cos 3x cos 2y cos h 3y, plus sin 3x, sorry 3 sin 3x sin 2y sin h 3y. This is the partial derivative of u with respect to x, which can be calculated easily. And similarly, we have the value of uy as e to the power of 2x times 3 sin 3x, sorry, only 3, only one, without 3. So sin 3x cos 2y cos h 3y, that is derivative 3 sin h 3y, plus sin 3x cos 2y is minus 2 sin 2y cos h 3y minus cos 3x cos 2y 2 times and sin 3y sin h 3y minus of cos 3x sin 2y into 3 times cos h 3y. This is the derivative of u with respect to y. So now we substitute. Now we have the function f of z uniquely, sorry, not uniquely, f of z as ux of z comma 0 minus I times uy of z comma 0 times dz plus c. Even one can see a similar kind of formula in terms of in terms of imaginary part, whereas then we get here vx and vy similarly, but this sign has to check, and here we get 0 comma z and 0 comma z dz, and the thing is this sign will get changed, and of course the constant will be similar, that will not be depend upon any of x and y. So now, but since here it is given the function u, so we use this formula. So now by using this formula we have integration ux of z comma 0, that as y is 0, that means so 2 to the power of 2z sin 3x, sorry, sin 3z, and the rest is 1 minus it is 0, this part is 0 since we have sin has 3y. So now from this part we have plus e to the power of 2z times 3 cos 3z, and from this part, since y is 0, we have sin 2y in this part, so that is 0. This is whereas ux of z comma 0 minus I times we have vy of z comma 0, and from the function, sorry, from uy we have since y is 0, and we have sin hy sin h 3y, that is 0, and similarly sin 2y, that is 0 again, and here sin h 3y sin 2y. So we can see all these terms are 0, so in total we get, that is uy of z comma 0 is 0. So in hence we have, in total we have as this term. So now doing the integration we get sin 3z times e to the power of 2z minus integration cos 3z times 3 e to the power of 2z dz plus, and the remaining term can be written same as it is, 3 e to the power of 2z cos 3z plus, sorry, dz plus c. So now from this we can see these two terms are getting cancelled. So in total we have, that is equal to integration, sorry, integration is not there. In total we have e to the power of 2z sin 3z e to the power of 2z sin 3z plus c, that is f of z. So now the question here is, what is the value of c? That has to be calculated from the given condition, extra condition, that is given as v of 0 comma 0. Since we have v of 0 comma 0 equal to 2. And from the given function, we can see u of 0 comma 0 can be calculated, can be seen. This is 1 and this is 0 entirely, and here it is also 0 entirely. So in total we have u of 0 comma 0 equal to 0. Why we should calculate u of 0 0 is because since we have the function f of z, so we can see the value of u of 0, that is nothing but c. So from the given condition, that is nothing but u of 0 comma 0 plus I times v of 0 comma 0, that is equal to 2y. That is, the value of c is nothing but 2y. Hence we have the total function f of z as uniquely e to the power of 2z cos 3z plus 2y. So this is the entire function. Sorry, entire in the sense this is the value of the function f of z uniquely. So now from this, the value it is asked to calculate is f of I pi. So from this we see f of I pi is nothing but e to the power of 2 pi I plus, sorry, not plus, cos 3 pi I plus 2i. So this is equal to e to the power of 2 pi I is 1 and cos 3 pi I. Sorry, it is sine. Sine 3 pi I. So with the definition of sine, we can see sine 3 pi I is nothing but sine h 3 pi plus 2i, and sine h 3 pi is nothing but e to the power of 3 pi minus e to the power of minus 3 pi divided by 2 and plus 2i. This is the value of f of I pi. But the whole value it is asked to calculate is 4 plus 2i times f of I pi is 4 plus 2i times e to the power of 3 pi minus e to the power of minus 3 pi divided by 2 plus 2i. Sorry, here sin h 3 pi is I times this value. Sin 3 pi I, the value of sin 3 pi I is I sin h 3 pi. That is from sin iz equal to I sin z. So now in total we have this as I times. So in total we have 4 minus of e to the power of 3 pi minus e to the power of minus 3 pi minus 4. So in total we have e to the power of minus 3 pi minus e to the power of 3 pi. So from the given options we have option B is the correct option. Sorry, option not option B, option C, that can be seen e to the power of minus 3 pi minus e to the power of 3 pi. So option C is correct. Thank you.